of inverses and trig inverses. First, let's think of inverses. Okay, the graphs and slopes at given points. So we have this graph right here. All right, and we have f of x, which is x squared, and g of x, which is the square root of x. All right, and they are inverses. Trust me, they are. So this graph on the left that is increasing at a faster rate is x squared. And this graph that is increasing at a slower rate, the one on the bottom right, that is radical x. Okay? All right. So, please remember and recall that for inverses, graphically, they reflect over y equals x. Over y equals x. Okay? Which means, if this point right here, 2, 4, is reflected on the inverse, it is going to be at 4, 2. That will be at 4, 2. And that's very important to realize to know. Right? So your x and your y for the inverse literally flip. Alright? So, if your coordinate flips, so does your slope. Alright? So does your slope. So, your slopes are really just reciprocals of each other. Alright? They are literally just reciprocals of each other. For example, right here at point 24, if I were to find the slope of this line here, this tangent line, it touches right at 2,4. That slope has a value of 4. It goes up 4 over 1. Up 4 over 1. It's the same thing as 4 over 1. All right? Now, for our inverse, that inverted point, which is now 4, 2, that slope of the tangent line that touches at that point is 1 over 4. It is literally the reciprocal, it is flipped. Just like the coordinate, the x and y flips. For the slope, the numerator and denominator. There aren't those x's and y's. Changing y over changing x, they flip as well. If the coordinate flips, why wouldn't the slope flip? It does. The only thing you need to be careful of, is if they ask you for the slope of the original function at x equals 2. So they'll say, what's the slope for the function at 2? Well, that is a slope of 4. If they ask you for the inverse, this is the inverse. It's not going to be at 2 that's 1/4. It's at 4. That's the one thing that I don't want you to get tripped up on. And how come? Because these coordinates flip. It's now the x value is 4, so that's going to be a 4. That will not be a 2. That will not be a reciprocal slope. That will be something else. Okay? And that's the one thing that you can get tripped up on. So, with this in mind. Yeah. The derivative of the inverse is equivalent to 1 over the original function. It's the reciprocal. Okay. It's 1 over the original function. Correct. A typical problem using that formula might look like this. If you're given f of 3 and it equals 5, okay? Now let's not forget, this is the coordinate x and y value. So when I do the inverse, they switch, right? The 5 now becomes the x value, doesn't it? That is going to equal 1 over the derivative of the function at that point. The derivative of the original function at 3 is 6. So that would end up being 1 over 6. Because they're asking why I flipped, and they're asking now for the y of the original, which becomes the x of the inverse. Okay, I want to stress that. Alright? Your trig inverse derivatives. Okay? Brace yourselves. The derivative of the inverse of sine is 1 over the square root of 1 minus u squared. Whatever the u is next to the sine. And this is 2x. If it's the sine negative 1 of 2x, your u here is 2x. And you have to take the derivative of 2x, which would be 2, wouldn't you? Chain rule. You always do it. If it's an x, the derivative of x is just 1, so you don't have to write it. You're always doing chain. So, if the derivative of the inverse of sine is 1 over the square root of 1 minus u squared, what do you think the derivative of the inverse of cosine is going to be? Take a look at this and try and figure out what you think this is going to be. The negation of it. Just the negation of it. Because cosine, negative sine, when you do regular derivatives. So the inverse of cosine is literally negative whatever the inverse of sine is. Derivative. You see what I'm saying? How you put that together? You see this? See this right here? That's the derivative of the inverse of sine. Okay? When we think of the regular derivatives of trig, cosine is negative sine, isn't it? Isn't this negative? And isn't this really what the derivative of the inverse of sine is? So it's still literally the negative sine value, because this is sine. I'm trying to get you an easy way to think. So now you got to remember 1 and just negate it for cosine. Remember, c is always going to be negative. So let's say tangent. There's no radical, there's a plus in the bottom. It's a little bit more pleasant. It is 1 over 1 plus u squared. The derivative of the tangent, the derivative of the inverse of tangent is 1 over 1 plus u squared. Okay, the derivative of the inverse of cotangent, these last 3 aren't as common. Okay, they might give them to you as examples in the book because they've already given you a sine and cosine and tangent inverse derivative. But there you go. It's the negation of the tan inverse. So it's negative 1 over 1 plus u squared times derivative of u. Don't forget. Chain rule in effect. All right. Good. Secants is weird. Yeah, when you do homework problems, you'll have this referred to. I would never throw this on a test for you and expect you to kind of remember that. If you did, then kudos to you. That's fantastic. And when you become engineers or whatever it is, and you have to look at formulas or whatever it is that you do, you'll be able to look at a book. It's not going to be a test because your company's profit and money is dependent on your knowledge. And if you reference a book to save the company 10 grand, they're not going to say, no. You need to memorize it. They're going to be looking up in a book. So, and cosecant, that's just a negation. It's the change. Well, what is derivative in general? It's slow. It's the rate of change. It's the instant rate of change, not the average. So all these things, anything that's curved or whatever, that has any sort of movement or velocity, it alters its movement. That'll be do anything. What do they got? Spin or something that's rolling around on the inside. And you find a chain right at the inside. When the Viper, the Viper goes in a loop. And someone wants to know how fast you are right at a certain point because that might I know someone falling out in that. I would assume that it's trig. It's like a perfect circle. It's more FYI, isn't secant 1 over cosine back in the day? And cotangent is really 1 over tangent, which is the flip of tangent. And cosecant is 1 over sine. Well, for the inverse, it kind of holds true. You can see this here, except that cotangent one is... It's always tangent, cotangent, for the curve. Okay? I wouldn't worry too much about these substituting formulas. They're just, again, FYI. Sometimes it might make life easier to do it that way, sometimes it might not. Okay? So, find the derivative with respect to y of the following function. Alright? Y equals the inverse of cosine of x squared. Alright, so, first we need to know, what's the, yeah, you know what I mean, the thing, the derivative for that. Cosine, so it's the square root of 1 minus u squared. The squared is with the u underneath, times du, right? So, this is my u. Oh, yeah, you can and can't. Not necessary, but I will put it there because that's what the thing says. So, my x squared is u. So I'm going to say negative 1 all over 1 minus u, which is x squared, times, what's the derivative of u squared? Times 2x. Wait for it. When I multiply that, I have negative 2x on the top over 1 minus, what happens when I square x squared? No, because it's a 1, square of 1. And that's it, right there. The square with square is like that's why I was like the square is underneath.